We have already seen in this class that it is useful to classify chemical elements and chemical compounds into several categories, such as metals and nonmetals, molecular and ionic compounds, and so on, because the elements or compounds within each category have similar properties. In the same way, it is useful to classify chemical reactions, because reactions within each class occur somewhat similarly. There are several approaches to classifying chemical reactions. We will start by considering a classification for reactions that occur in aqueous solutions that is based on what kinds of reactants are mixed together or what kinds of products are produced. The first type of reaction that can occur in this classification is a precipitation reaction. A reaction between two aqueous solutions that results in the formation of a solid, the precipitate. Let's consider the following example. A reaction between potassium iodide in aqueous solution and lead-2 nitrate in aqueous solution leads to the formation of lead-2 iodide, a solid, and potassium nitrate in aqueous solution. We combine aqueous solutions of potassium iodide, all ionic compounds that contains the potassium plus ion are soluble in water, and of lead-2 nitrate, all nitrates are also soluble in water. To form the products, the cation from the first reactant, potassium plus, combines with the anion from the second reactant, NO3-, forming potassium nitrate, KNO3, which is soluble in water. The anion from the first reactant, I-, combines with the cation from the second reactant, lead-2+, forming lead-2 iodide, which is not soluble in water. Although most iodides are soluble, lead-2 iodide is an exception, as we have said in the previous video. The insoluble lead-2 iodide forms an ionic solid, the precipitate, that eventually settles to the bottom of the reaction container. In this reaction, we combine two aqueous solutions and form at least one product that is not soluble, in this case, lead-2 iodide. Therefore, by definition, this reaction is a precipitation reaction. Let's watch this reaction on video. The yellow-colored compound is lead-2 iodide. Small solid particles of it are formed throughout the solution and will settle to the bottom of the container over time. The second type of reaction that can occur between two reactants in aqueous solution is a gas evolution reaction. This type of reaction results in the formation of a gas. Consider the following example. The reaction between sulfuric acid in aqueous solution and lithium sulfide in aqueous solution leads to the formation of dihydrogen sulfide, a molecular gas, and lithium sulfate, an aqueous solution. In this reaction, the first reactant is an aqueous solution of an acid. Remember, acids, like ionic compounds, tend to dissociate when they are dissolved in water, and sulfuric acid dissociates into H+ cations and sulfate anions, SO4₂-, almost completely. The second reactant is an ionic compound, and like all ionic compounds that contain lithium+ cations, it is soluble. Similarly to the previous reaction that we considered, the products are formed by combining the cation from the first reactant, H+, with the anion from the second reactant, S2-, and the cation from the second reactant, lithium+, with the anion from the first reactant, SO4 2-. The first product is a molecular compound, dihydrogen sulfide. It is composed entirely of atoms of nonmetals, hydrogen and sulfur. At room temperature and atmospheric pressure, dihydrogen sulfide is a gas. The second product is a soluble ionic solid, lithium sulfate. In this reaction, we combine two aqueous solutions and form at least one product that is a gas, in this case, dihydrogen sulfide. Therefore, by definition, this reaction is a gas evolution reaction. In some gas evolution reactions, the gas is not formed directly. Rather, one of the products of the initial reaction turns out to be unstable and decomposes, and one of the products of that decomposition is a gas. An example of such a reaction that proceeds in two steps is the reaction between sodium bicarbonate, NaHCO3, more commonly known as baking soda, and acetic acid, HC2H3O2, a major component of vinegar. The first product of this reaction is sodium acetate, NaC2H3O2, a water-soluble ionic compound that is formed by combining the cation from the first reactant, sodium plus, with the anion from the second reactant, C2H3O2-. The second product of this reaction is carbonic acid, H2CO3, that is formed by combining the cation from the second reactant, H+, with the anion from the first reactant, HCO3-. However, it turns out that this carbonic acid is unstable. It rapidly decomposes, that is, its molecules fall apart, forming carbon dioxide gas, CO2, and liquid water, H2O. The carbon dioxide gas then escapes from the vessel in which the reaction is performed. Because one of the products is a gas, the overall reaction is a gas evolution reaction. Let's watch a video recording of this reaction. Go.
All day we can breathe.
You can see bubbling as carbon dioxide gas is formed and escapes from the solution. The carbon dioxide starts forming as soon as acetic acid is poured into sodium bicarbonate, meaning that carbonic acid decomposes very quickly. Although the overall reaction proceeds in two steps, with the carbonic acid formed in the first and decomposed in the second step follows the first almost instantaneously. Here is a table of common reactants that you will see in gas evolution reactions. They are sulfides. There is no intermediate product, and the gas evolved is dihydrogen sulfide, as we have seen in one of the reactions that we considered. Carbonates and bicarbonates. The intermediate product formed is carbonic acid that decomposes with the release of carbon dioxide, as we have seen in another reaction that we considered. Sulfides and bisulfides. The intermediate product formed is sulfurous acid that decomposes with the release of sulfur dioxide. And ammonium salts. The intermediate product formed is ammonium hydroxide, and the gas evolved is ammonia, NH3. A third type of reaction that may occur when two aqueous solutions are mixed is an acid-base or neutralization reaction. In such a reaction, as the name implies, an acid in aqueous solution reacts with a base in aqueous solution. We have already talked about acids, but let me remind you that in this class we define an acid as a compound that can dissociate in solution into an H+ cation and some anion. We will define a base as an ionic compound that can dissociate in solution into some cation and a hydroxide anion, OH-. These definitions are not universal, but are sufficient for the purposes of our course. Here is a non-exhaustive list of some common acids and bases. We have already looked at acids and are familiar with the acids on this list and with the naming conventions for them, so let's take a closer look at the bases. As you can see, per the definitions that we used, all of the bases contain the hydroxide anion, OH-. The cations vary. Mostly they are metal cations like K+, Na+, Ca+, Ba2+. Although bases can also have polyatomic cations. The naming conventions for bases are the same as for other ionic compounds. Because per our definition, the anion in a base is always hydroxide, the names of all bases end in hydroxide. For example, KOH is potassium hydroxide, and CaOH2 is calcium hydroxide. What happens when we mix together aqueous solutions of an acid and a base? Let's consider the following example. A reaction between hydrochloric acid in aqueous solution and potassium hydroxide in aqueous solution. In the same way as for the reactions that we have considered earlier, the cation from the first reactant, the acid H+, is combined with the anion from the second reactant, the base OH-, forming water, H2O, a molecular compound that is liquid at room temperature and atmospheric pressure. The cation from the second reactant, K+, is combined with the anion from the first reactant, Cl-, forming the ionic compound potassium hydroxide that is soluble in water, as are all compounds that contain the K+ cation. Ionic compounds that can form as a result of an acid-base or neutralization reaction are referred to as salts. Note that table salt, sodium chloride, NaCl, is just one compound in the broader class of salts. Any neutralization reaction, that is, any reaction between an acid and a base, results in the formation of water and a salt. So, if one is looking at a reaction between two reactants in aqueous solution, how does one find out what types of reactions they are? If one of the reactants is an acid and the other reactant is a base, we have an acid-base or neutralization reaction. The products of this reaction will be water and some salt, an ionic compound. If at least one of the products of the reaction is an ionic compound that is not soluble in water, the reaction is a precipitation reaction and the insoluble compound will be a solid precipitate. If at least one of the products of the reaction is a gas, the reaction is a gas evolution reaction. The gas will typically be a molecular compound. You will note at this point that if two reactants in aqueous solutions were combined and all products that could be formed as a result of the reaction were ionic compounds that are soluble in water, then such a reaction would not occur. Try to figure out yourself why that is the case based on what we know about ionic compounds that are soluble in water. We will return to this question in the next lecture.